So my name is Andrew Bell, and I'm a technology research fellow at an ad agency called the Barbarian Group. I'm hoping I'm the only person at this whole conference from an ad agency. Tell me, don't tell me if I'm not. I'm pretty sure I am. And I run an open source project called Cinder, which is a C++ framework for creative coding that we'll talk about some more shortly. Let me give you all just a sense of kind of where we're heading over the next hour. We'll start by trying to define this term, creative coding. And then we'll look at some work that has been done in that sort of genre. And hopefully you'll find some of it inspiring and maybe trigger some ideas for your own kind of projects. And then last, we'll look at how you could get started doing creative coding yourself if you aren't already, and with a particular eye towards Cinder specifically. So let's start by defining this term. And I should say that creative coding is not my term. I didn't invent it. I wouldn't have invented it. But somebody did, and it stuck. And it has a couple of problems. Probably the biggest problem, I think, is just that it kind of does violence to the fact that all programming is creative, right? That's probably a lot of what appeals to you about programming at all, is that it's this very creative act. You're making something out of nothing. This sort of abstract creation is pretty sweet. That's probably why you're here. That said, when we say creative coding, we kind of mean it in a different sense of the word creative, right? So the way I would define it is creative coding is programming with aesthetic intent, meaning sort of the work product, as it were, of creative coding is meant to be something that's visual or that's interactive or is driven by audio, whatever your particular project may be. It's ultimately meant to be a sort of sensory result. But probably the easiest way to define it is just by way of example. So I'm going to run a clip for y'all that these are all projects that were made with Cinder specifically, but it's really meant to be, I think, indicative of what the larger world of creative coding is up to. So I'm going to run this and then we can do it. So hopefully that, just by a very brief introduction gives you a sense of what people usually mean when they say creative coding. It's projects like that, large-scale touchscreens, interactive displays, tablet apps. There's all kinds of things that fit under this kind of umbrella term. And I'd like that to lead into this quote from Bjarne that probably a number of you have run across. Basically, nobody knows what most C++ programmers do, right? So at this conference, you're going to find every possible problem domain represented. They're all pretty different from each other. And part of my intention in this talk is to call your attention to a way that C++ gets used that may be really different. If you work at the JPL or you work at any number of places, you'll find people doing pretty different stuff from what we'll talk about today. But I do think it's important, especially in a conference devoted to C++, to think about the fact that we're all up to really different things. For me, this is probably some of the most fun stuff, but there are other people that like to write self-balancing binary trees. So there's also, I think it's relevant to think about this C++ renaissance that Herb Sutter and others have talked about that I really think is legitimate. I mean, I think your presence here today is a product of that renaissance, right? I think there's new attention being given to C++. In particular, the committee is on fire. There's a lot of interesting things happening around the language. And I actually believe that creative coding plays a pretty key role in that. And the reason is, particularly if you're not involved in the creative industry or in education, there's a kind of a new phenomenon, in my view, in terms of the way that young people are getting into programming. And it specifically begins, in a lot of cases, with HTML. So they use the verb coding around HTML, which probably makes most of us cringe, but that's what people say. And in that very early introduction to programming, markup, visual results, layout is inextricably linked to code. That is your entree, and then you start to introduce a layer of abstraction that's a little different. You have CSS, that is a little more abstract, and then ultimately we introduce logic with JavaScript, and that's probably the only time you'll hear me use the words JavaScript and logic in the same sentence. But in a formal definition of logic, we have client-side code that's executing in the browser. But again, all of this is very tied to visual results and interactive results. And that's probably really different from how a lot of people in this room came into coding. You didn't start with something that was fundamentally visual or even creative in this sort of loose definition that we're working from today. And in light of that, there's a lot of schools teaching this stuff as a formal discipline. So programs like the Design Media Arts program at UCLA, ITP at NYU, RIT has always had a really strong discipline in this arena. And these are even graduate level programs that are combining code and design. They're teaching designers whose bread and butter might be Illustrator or After Effects how to code. And this is contested space from the perspective of C++ coders, right? So your typical creative coder, whether they're a hobbyist or whether they're professional, move between languages and tools constantly. And you can kind of make an argument of a jack of all trades kind of thing there. But fundamentally, this is what's going on. I would say that processing is probably the most popular tool for creative coding. Processing is essentially a wrapper around Java. You also have JavaScript, of course, and in particular, technologies like WebGL are exposing a lot of the power of the GPU that we got to kind of have exclusive rights to as C++ and as native code for a long time. We don't have exclusive rights, and all these web guys are hanging out on the GPU. How did they get here? And then there's proprietary tools, right? So tools like Flash, which is maybe on its last legs, but is still, it's making its stand here in creative coding. And then tools like Unity that are fundamentally game development tools, but are appropriate for certain kinds of creative coding. So in that sense, C++ has something to prove. And there's a related question. Is C++ a good choice for creative coding? I would say no, and also yes. So I'm biased. I run one of the larger C++ creative coding frameworks. But it's worth pausing and talking about why it might not be a good choice. So the primary one, in my view, is build times, right? So creative coding is a fundamentally iterative process. Just like any form of design is very iterative. You make a couple of changes and then you see what that looks like. And when you wait a whole minute to see what that looks like, kind of kills the flow. And the other aspect is this 90-10 rule that we're all pretty familiar with, right? That says that your app spends 90% of its time in 10% of its code. C++ sucks for writing that 90% a lot of times. There's different causes for this. In my view, there's a little bit of pedantry in the STL that's like, oh, well, you can't do that because it's slow. If you've ever tried to teach someone C++ and you've had to explain that the reason that you can't push front on a vector is because it would be slow, the inevitable response is, why does this language hate me? And JavaScript would never do this to me. And I think there's something to that. There's been a certain perspective in our community that said, you shouldn't do anything that's slow. But it's a little bit willfully ignorant of this rule that says most of the time, actually, performance doesn't matter. And things like Amdahl's law formalize that notion. That's the last time I'm going to say anything that nerdy. The rest of the time, it's going to be friggin' sweet. But to close this thought, where C++ really shines is in that 10% where you do care about performance. And creative coding is the kind of discipline where we're like really, really interested in that 10% running fast. That's, if you've ever played a game that's losing frames, any kind of interactive experience that's not able to keep up with the participant really falls on its face. And so creative coders are actually quite interested in performance. And then, of course, C++ really has a wealth of libraries, and a lot of creative coders are just looking for non-obvious ways to use different kinds of APIs or things in that genre. And then finally, we have access to hardware, and I mean that in both senses, right? So we can get really low level if we need to, and occasionally we do, but also it opens up some interesting new kinds of hardware like the Kinect and the Oculus Rift that we'll talk about shortly. So let's look at some work. And again, a lot of my attention here, in part, is that I feel like this is kind of a victory lap for C++. I mentioned this is contested space. C++ is actually not winning this war, and by a certain measure is kind of losing the war in creative coding tools. But these are all projects that were built with Cinder and C++ by extension. And my other intention in reviewing this work is just to give you a sense of the kinds of things that are possible, and really, hopefully, might spark some creative ideas for projects that you might take on yourself. So let's get started with a first project. This is from a company called Murata, which is essentially Guillermo del Toro's post-production company. And this was built in service of IBM. This was to celebrate the IBM centennial. This was installed at Lincoln Center in New York City. That's a 110-foot display that's visualizing in real time all kinds of data, everything from the traffic patterns in Manhattan to air quality, and it's all being rendered live using a Cinder application. Or you could write a self-balancing binary tree. This is from a company called Collision. This was done for Audi. So you see this is a people tracking sort of implementation that's using depth cameras from the ceiling, and then a really clever use of LEDs. We've all seen these used as walls, but you don't typically see them used as floors. So they're able to track visitors and then render imagery directly beneath their feet. You might have seen this done with projectors, but the advantage here is there's no shadow. So a really, I think, compelling result there. A company called Hush built this for Nike. This was for the Olympic running trials. This was in Camp Victory. You see these treadmills are special treadmills that know how quickly somebody's running on them, and then they built a head-to-head race that's visualizing how these two runners are running relative to one another. I like this example because it shows what a nonprofit can do if you give them access to the same kinds of tools that often big brands and advertising executions use. So Charity Water is a pretty well-known clean water charity. They do a fundraising ball every year. This is 2,000 people at the Armory in New York. And they built a number of interactive exhibits like that that shows you how much water you've pumped relative to what someone in the developing nations would typically have to pump per day. We've got traditional touch screens behind mirrored glass for additional education. And then that is sort of the star of the show. That's an RFID bracelet that allows guests to the party to bid to participate in the fundraising live, so you can see they're able to visualize the names of people as people came forward to pledge money. You would see those sort of roll up the screen, and then they created a party environment around a thing that's like fundamentally sort of a bummer, which is like giving money away. But it made it be a sort of shared environment where everybody was in pursuit of the same goal. It really successful. This is a little company called Field, based in London, and they did this project. This was installed at La Gaîté in Paris. And what you see here are tiny little creatures that have evolved over time to sort of have various appendages, and they become more complex, and they're reacting to the audio that's in the space. So I don't have audio on this clip, but if you were in that room, you'd see all these little creatures dancing to what I can only assume is techno. Breakfast is a little shop, also based in New York. They did a great project. They rewired those flipping dot displays that you see on the side of the highway that are meant to run at around 2 frames a second. They're running them at 30, and they use a special depth camera from Panasonic, and they were able to build this interactive sign that was installed, I think this was near Lincoln Center, actually Herald Square. This was promoting the TNT show called Perception. The Mill is one of the world's oldest, biggest visual effects companies. They wanted to do something in their lobby to make an interactive version of their 20-year portfolio. So they created this multi-touch piece of glass and then put all 1,000 or so projects on there, so clients that are visiting are able to pull up any job. And then interactions like this is a lens that shows in real time before and after the visual effects project. So as you drag the lens across, you can see through to the blue screen or whatever was there prior to when the mill got paid millions of dollars to change it. A company called Fathom is a data visualization company based in Cambridge. This is a nice example of something more in the tablet space. So these, again, creative coding certainly not limited to big projections and the like. This is an interactive version of GE's whole history of their annual reports. You think of an annual report as a relatively dry document, and I think they are. But GE's have traditionally had really beautiful design that's really indicative of its era. And so Fathom built this piece that allows you to really see this whole history of these really beautifully designed reports. A company called MID, they're installed this at the Pablo Picasso Museum in Barcelona. And part of why I have this example is it shows yet another sort of facet of the creative coding world is in the museum world. You probably don't need me to tell you that museums are moving more and more to this style of exhibit where you have interactive sort of technology-driven exhibitions. And if you imagine yourself to be a museum, you're competing with the internet, you're competing with movies. If you talk to, I had a conversation with a design director of a well-known museum recently, and who they compete with is not other museums. It's just like, I don't want to go to the museum is a big part of their sort of what their pushback is. And so they have to build things that are able to compete with video games and movies and that sort of thing. For better or for worse, that's sort of what it takes to draw people in. Stefan Sagmeister is a pretty well-known designer, and he built this. This was installed at a museum in Philadelphia. This is using very sophisticated smile detection software that came out of psychology research, but for a really artful purpose. So when you smile, you ignite this sort of projection mapping onto these sugar cube sculpture. And again, a lot of creative coding is sort of using libraries in ways that God never intended, for some sort of creative purpose. This is a nice example of a trend we're seeing a lot, which is creative coding taking over retail. This was a Nike store in Australia. And one of the nice touches on this is rear projected glass. That's the physical display. It allows the store to function as a store even when the lights are off and there's nobody home. And you can see in that the physical lighting within the space would highlight products that the screen is sort of depicting in concert. Is a nice execution. And then this is a little boutique that I'm a big fan of. They're based in Brooklyn. They do projects like these. This is another head-to-head kind of race that's being driven by a physical means. This was installed at the Museum of Moving Image for Sonos. This is another highlight. They wanted to projection map onto the surface of a swimming pool. So they covered it in ping pong balls, which of course can reflect enough light for you to project, unlike water. And looks like a pretty fun party. I think that's a metaphor for all of C++, pretty much. It's just a co-ed party. And then MIT, of course, does a lot of cutting-edge research of just about any variety you can name. This is some of their HCI research being done using Cinder in part, and this is a shared virtual environment. The iPads serve as windows into that environment. Of course, they have really sophisticated hand tracking technology. And what we're seeing through is, I think, rear projected onto glass. If you work in this space, the only thing anyone can ever think of is Minority Report. So like, if I'm explaining to someone's mom what I work on, inevitably the sentence, oh, like Minority Report will emerge at some point. I think these guys have a fair claim to being like Minority Report, though. This was a project that Wyden and Kennedy did. This was installed in the beaches of California. I think this may be in Venice. And basically, they wanted to depict how many calories it takes till you've earned a Coca-Cola. And so it turns out the number is 140 for the average person. And so they rigged up this bicycle that knows how far you've gone and also has some pretty fancy electronics for estimating your weight and things like that. And then they built this really insane device that is obviously unnecessary but a lot of fun, that delivers you a free Coke. And my understanding is a huge success, and I think it's worth saying, C++ Cinder is at the heart of this. It's connecting a bunch of different pieces of electronics and sensors, and is obviously a pretty fun way to spend a day writing native code. And then just as the last example in this genre, I'm going to show a piece that I just finished up with my full-time employer. This was done for Samsung, so picture this installed in places like Best Buy and Lowe's and these sort of retailers. I'll talk briefly about it. I'm going to run this clip though. Sometimes people ask, we actually do have a trademark on the phrase, it's going to be awesome, strangely enough. So this will just kind of round out this section, and then we'll switch gears a little bit. But part of why I show this, besides the fact that it ruined my life for 9 months, was that it actually shows some of why we're interested in C++. So this project had a lot of people working on it, and had a good bit of money behind it, as you might imagine. And enough so that we were able to build multiple prototypes in advance. And we did so in Flash. Flash is actually a really natural tool for a project like this. And we had a really crack team of Flash developers, but they hit a performance wall, and it wasn't their fault. The tool was the actual bottleneck. And because we were working in Cinder, we had full access to the hardware I was using, extensions that came out a few months ago from NVIDIA for OpenGL. We did a totally custom video pipeline, because this is 12 times 1080p. So an Xbox or whatever would typically be driving 1920 by 1080. This is actually over 12 times that many pixels in real time. And we're, of course, dealing with multi-touch. There's these massive assets. The whole thing is controlled by a global CMS, so some Korean guy can push a new refrigerator out to the world, and that shows up in Iowa. So it's pretty fancy, and I think is indicative of where a lot of this kind of work is heading, right? So we've had these sort of early beginnings at relatively small teams, a lot of times teams of one, but I couldn't give you an exact count, but I mean, like the computer graphics in this is done by the same company that did Transformers 4, for example. So like, this is becoming a legitimate way for you to feed your babies, is writing code like this. That said, let's switch gears a little bit and talk specifically about Cinder. So Cinder is an open source library for creative coding. Everything you just saw was made with Cinder. And just some highlights, it's pretty modern C++. Our bottleneck is Visual Studio 2012 is sort of the feature set that we target, and up, it's the baseline, sorry Microsoft. It's FreeBSD licensed, so you don't owe me anything, you don't owe anybody anything. If you use this to feed your babies, you can fork Cinder and do horrible things, and you don't owe anybody anything. And people do. And of course, a lot of our commercial users also give code back, but you're not required to. It supports OS X, Windows, iOS. We recently had a very generous contribution from a team at Microsoft who did a full port to WinRT, which is still nascent, but it allows us to run on the service as well as the store in Win 8. There's unofficial ports to Android and to Linux. As an example, I know Google ported Cinder to Glass before anybody heard of it, and was doing a lot of the UI prototyping using Cinder on the device. So there's been commercial apps released, but we don't quite support Android natively. If you're hanging out in this room and you're a big Android fan, we'd love your help. And then, of course, Cinder has a global user community. That's really from all walks of life, besides the fact that you program computers all the time. That is a common thread, but other than that, geographically, whether you're doing this work professionally or as a hobby, you can find users of just about any stripe. Some specific technical features. So we have code implemented for pretty fancy math. So if you're used to graphics programming, then you'll find the kind of math primitives that you would expect, vectors and matrices and quaternions. We support OpenGL and Cairo, and DirectX is experimental right now, courtesy of the WinRT work. We have pretty solid video support, largely through QuickTime, but we also can interface with things like webcams or other video input devices. We can play back and record movies as well. A pretty fancy new audio API just came out a couple weeks ago. So if you're interested in things like sample accurate parameters and things like that, we got them. And then, of course, high-level primitives for just playing back audio, that sort of stuff. User interface like you'd expect, the mouse and the keyboard. Also, support for multi-touch. So we can abstract, say the way that Win 7 does multi-touch is pretty different from the way iOS does multi-touch. But if you talk to Cinder about multi-touch, it's uniform and sort of predictable. We support networking, of course, so if there are any ASIO fans in the room, this is up for TR2 right now. We support that. We actually embed Boost right now, although that may change with time. Boost may not be strictly necessary in the future. And we can do things like load resources over HTTP, friggin' XML and JSON, baby, one of the most glamorous possible features. We got it. And a lot of different kinds of companies are using Cinder. So on the commercial front, we have agencies that you might have heard of, like Ogilvy or Whiten, well-known design firms. Pentagram's a nice example of that. Pentagram is a pretty well-known graphic design firm. I think they say you can only travel like 2 minutes in Manhattan without seeing something that Pentagram designed. We have the usual suspects in terms of technology companies. And then companies like Industrial Light and Magic that live in sort of the visual effects space. Yeah?
Is your Cairo backend hardware accelerated?
No, that stuff, if you're asking, you're probably familiar with Cairo, and that stuff is a little bit experimental still. So for now, we're not shipping it, but I'm hoping Cairo will kind of square that away in a way that we can use. Strangely, Cinder won a big ad award that probably most of the people in this room, if you've heard of Cinder, it's through Herb's Going Native talk. Herb spent some time on it in his talk last year, his keynote. If y'all were ad people, which is who I'm often talking to, this is a big deal to you. It's not a big deal to probably anybody in this room. But strangely, we won what's considered the highest award in all of advertising with open source C++. That's just freaky, but it's true. So the first Grand Prix that was ever given for innovation was given to Cinder, and so we have this weird lion-shaped trophy that costs $3,500 to replace if you ever want your own. Also, Cinder is in the Smithsonian in this kind of weird way. I think Herb might have mentioned this. So this is an app called Planetary that was built with Cinder. It's an iPad app for sort of music exploration, and it became the Smithsonian's first code-based design acquisition. So the Cooper Hewitt represents the design collection of the Smithsonian, and this was their first acquisition for a piece that was driven by code. So I guess there's like a printout of the source code in some dusty hall at the Smithsonian somewhere for Planetary. Very brief history of Cinder. Begins with me being the president of my high school's computer club, which you would clearly join to meet women. I moved into working in visual effects, so I took code that I was writing since high school with me to work on projects like these, and the kinds of problems that VFX people are solving is very related to creative coding. In some ways, it's the same kind of thing, much as games development overlaps a lot. So working on stuff like this, writing code, and then I moved to Barbarian Group, and my first project at Barbarian, a guy named Robert Hodgen and I wrote the music visualizer that's in iTunes. So if you're a drug user, then you're probably familiar with this. But we also built the first augmented reality issue of a major magazine. This was for Esquire. And so you could hold up the magazine and you could see content. And that marked the end of Cinder as a closed source project. So it was around this time that Barbarian decided, let's take a bet on Cinder. And the bet is that it will actually pay more dividends for Cinder to be an open source project than a proprietary closed one. And I don't think this is obvious, right? So you could do a whole talk on this topic of the relationship between commercial entities and open source. This is a pretty unique one because Barbarian arguably had a competitive advantage relative to other advertising agencies in having a tool like Cinder. And they chose to make a bet that it would be more useful out in the world. And to be very frank, some of the dividends that something like this pays, if you're ever arguing with your employer about this, is in large part in hiring, right? So a lot of people that would have never heard of Barbarian Group, everyone in this room extremely would never have heard of Barbarian Group probably were it not for Cinder, right? Who cares about freaking advertising? Only me. But now you have, and we're interested in people like you, and creative coding world at large, I should say, is very interested in people like you. If you demonstrate some Cinder skills, send me an email, and I guarantee you I can get you a job writing Cinder all day, every day. There's definitely a market for that, and I don't even mean at Barbarian. Just I get emails constantly. We need Cinder people. We need Cinder people. So it's something to consider. I'm not trying to. I'll try to poach y'all to a new industry. You know, you can work wherever you want. But all that said, Barbarian took a risk, and I believe that it's paid dividends. So let's look at some code, because this is a freaking C++ conference, baby. We'll look at kind of the canonical stripped-down Cinder app first. Now, you can use Cinder just as a library. You don't have to use it to build a whole app. You could be writing a plugin and just link against Cinder if you choose to. But most users wouldn't. Most users are building a whole project. And so they look kind of like this. So we have our own app class that we derive from Cinder's app native. There's a number of different kinds of apps. And then you just override virtual methods. Setup gets fired once. That's when the app launches. And then update and draw get called in a loop forever. And then you can override different kinds of input, like say mouse down or key down. There's a number of different ones. For more obscure events, we have a signals and slots system, but just for convenience, you can override virtual methods like these. And then we have an app instantiation macro at the end that just does sort of black magic to make a real app on whatever platform you're in. Yep.
Is this single-threaded or multi-threaded?
It's multi-threaded in the sense that people write multi-threaded apps a lot with it. You know, you have to be a little bit aware of, it's pretty traditional event-driven style if you've written Win32 or that sort of thing, where the primary thread is sort of implicitly the only thread allowed to access certain resources, but then you can write multi-threaded all day long, and people do. That Center Stage project has an unreasonable number of threads, for example. Just to get y'all a little bit of exposure, and then we'll look at some more concrete examples. Cinder has a CPU side image class called surface that just represents a pile of pixels. So you might ask the webcam for the latest frame, for example, and that would come back as a surface. Then we have GPU side images. These are, we're going to use GL because that's kind of the most standard, but this would be a GPU side image, a texture. If you've written GPU code, all this is very familiar. If you haven't, it's worth knowing just briefly. Obviously, the GPU has its own memory. Traditionally, one of the primary bottlenecks is getting things off of the CPU and onto the GPU, and God forbid, the opposite. And so, all that said, it's pretty easy with Cinder to just instantiate a texture using a CPU side image. We can also instantiate a texture with the result of a load image. So, you know, load image, among other things, can take a file path, and you know, if you have a favorite cat as ping, that could be a GPU resource in just one line of code. Similarly, if you wanted to say load an image off of the internet, then you could fire load image up against the result of load URL, and I'll go do the things for you, like sacrificing a chicken, so that you know we do all the HTTP transport, and just magically an OpenGL texture arrives for you. It's worth saying Cinder's smart about noticing things like, hey, this image of a cat invasion was a grayscale ping, and there's a more memory efficient representation in OpenGL if we just have a single channel image. It notices that and will do the right incantations in GL to minimize the resource usage, for example. You can override that, but it would happen automatically for you. And then if you wanted to just draw your texture on the screen, you just call draw convenience method against texture. So that is just a real simple introduction. A room like this, inevitably there's a bunch of people smarter than me that are like, why should I use your framework when I'm so much smarter than you? And the only responses I would have, in part, the stuff I just described sucks to write. That's the most boring day you could ever have, is like having a conversation with libping. And I had those conversations for you, and I turned them into Cinder, and you don't have to have them. So a lot of it is just that. It's like, why do that stuff? That stuff sucks. That's not, I would rather just lick all the icing off the cupcake and let somebody else eat the cake. I ate the cake for you. So consider that. You're welcome. And then, you know, just avoiding bugs, right? So it's not that Cinder has no bugs, but there's a whole bunch of people banging on it that are going to increase the possibility, the probability that somebody's going to meet a bug before you do. And even better, they're going to send me a GitHub pull request. I'm going to merge that and you'll never meet it. So that's worth considering. Because it's true open source, and this is by way of contrast to some other options, there's no black boxes. So you can, you know, you can step in a debugger sense into the Cinder code, and you know, occasionally you might want to do that, need to do that. Because it's BSD, there's no legal encumbrances, of course, and you can interoperate with fellow human beings, which for a lot of C++ programmers is a low priority. But there is a lot to be said for it in some practical terms, in terms of just hiring or inviting people to work on your project. Another concrete example, no pun intended, of interop would be Cinder blocks. So this is an idea in Cinder where we sort of package up all of the stuff that is necessary to use a library. So, you know, many of us have spent a lot of hours dealing with like, why does this include, you know, directive fail on this particular whatever. And that's just on a practical term, a lot of what keeps people out of C++ is that stuff. That stuff sucks. And that is not the language, but it's an inescapable aspect of being a C++ developer. So a Cinder block is an XML representation that a tool I'll show you in a second can parse and will fix up all your paths and add stuff to your Xcode or your Visual Studio project. and stick linker flags where they need to go and copy static libraries over. And if it all works, and it generally does, then you've got OpenCV grafted into your application. Specific examples of Cinder blocks that are out in the wild with Connect, also the Connect 2, which Microsoft did a lot of nice work on. OpenCV for image processing, we'll look at an example of that shortly. Box2D for 2D physics, Bullet for 3D physics. The Oculus Rift, of course, has a lot of attention right now. There's the RealSense camera from Intel, which is a little bit underrated in my view. Is actually a really slick depth camera, that's sort of desktop scale depth camera that has Cinder support. You can do things like build a photo booth with your Canon DSLR with Cinder. There's a Cinder block for having a conversation with your 5D or whatever. Oddly, there's a brain-computer interface that has a Cinder block for it. So if you would like to put sensors onto your scalp, you can have a conversation with your Cinder app. So we'll look at a specific example. I'm going to take the Leap Motion. I'll run this little clip at you. You're probably familiar. I don't know for sure, but Leap Motion is kind of like a desktop Connect. I probably should say it's not as accurate or as robust as the Connect, but it works on a very different scale, and it's sort of for gestures and that sort of thing. This clip is it in its best light, but it gives you a pretty good sense. It's relatively indicative of its performance and capabilities. So if we were going to do a project with the Leap, we would download this Cinder block off of GitHub. My friend Steve made this one. You can, it's not that there's one and only one Cinder block for a thing, but I picked Steve's for the Leap because it's nice. You can see me git cloning into my blocks directory for my Cinder distribution. And by putting it there, all the paths kind of just work out of the box. And a lot of Cinder blocks come with examples, this one included. So I think this is Steve's skeletal app. So you should be able to just double click the Xcode or the VC project in this Cinder block and then plug in your new $79.99 Leap Motion, and you're doing that, and you've got the source code and it's just working. Tinderbox is the tool that makes all of this possible, so it looks the same on Windows and the Mac. And this is able, you'll notice that the template, because I've installed the Leap Motion Cinder block, one of the things available to me is the Leap Motion template. And the project templates are just meant as kind of a jump start for your own project. So I'm going to pick that template. I've just enabled Xcode in this case. This is a list of all the Cinder blocks that are on my machine. It's automatically picked the Leap Motion one because I chose that template. And I could do other Cinder blocks. This is where we're going to try to get. And I see 43, so I'm behind. So I'm going to turn up the juice here. But we'll walk through the code a little bit. So a lot of this is familiar, and you can see that canonical example. This particular app just has draw and setup. And then, code here is going to be both Cinder code and then Steve's Leap Motion Cinder block code. So, it has its own little API. There's a class called Leap Frame that represents one frame of data, which is typically the position of hands and fingers. Then we've got shared pointer. Cinder uses ref as a suffix idiomatically to mean reference counted shared pointer. So whenever you see a ref suffix, that's a type def first to shared pointer. And then we're going to make a 3D camera. Cinder's camera persp is a 3D camera. The setup method is straightforward. We have a little conversation with OpenGL asking for depth buffering, aka Z buffering. We set up our 3D camera, give it a field of view of 60 degrees. We tell it where to be in space and where to look in space. And now, the app's going to be doing something like that. We fire up a new instance of the Leap itself, and then Steve's block has a stood function for the callback. And so we just write a little lambda that says our local copy of the current frame is the frame we got passed in. Pretty simple. And then last, this is our draw method. So we clear out the screen with OpenGL. We set up our matrices, which is just the way we do sort of 3D transformations in OpenGL. And then we're going to iterate the hands that Leap told us about and within each hand there's one or more pointables, and a pointable is a finger, but you can like use a pencil or a fork or something, I guess. And then we just get a little data off of these. We ask them for each finger, what's your orientation, how long are you, where do you live in space, and then ultimately we use that, we call a method called draw color cube. That's kind of a debug method in Cinder, where we tell it where the cube should be, how big it should be, then we set our color to gray, and we draw a line from the end of the pointer to the beginning. And when we put it all together, it looks like this. So picture me in my hotel room doing this. And the leap is really responsive. I mean, it's 60 hertz. It feels really natural. And that, again, you know, we wrote actually 0 lines of code because the Cinder block just supplied all of that for us out of the gate. And you're off and running. You can do your own, probably more creative thing immediately without dealing with downloading the SDK and installing blah, 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 blah. Box2D is a nice example. Box2D was made famous largely through Angry Birds. It's the same physics engine that's in Angry Birds and made whoever countless millions of dollars. The guy who writes Box2D made countless zeros of dollars off of that. But so we're going to do the same kind of dance with Tinderbox, say we'd like Box2D, and this is where we're going to try to get. We're going to build a little app that lets me click and it just makes little boxes that behave in kind of a physically realistic way. Setup code that's pretty familiar. We're going to make a unique pointer to our Box2D world, and then I lazily have made a vector of pairs of the color and the box. So we got our vector of boxes. Some of this is particular to Box2D, so I'm not going to get too in depth with it, but it's all straightforward. And it highlights a kind of a Cinder philosophy, which is what you're learning as you learn this is not Cinder's weird wrapper around Box2D. It's just Box2D. So Cinder blocks typically serve as kind of shims between Cinder's native types and in this case Box2D's native types, because we would rather you actually master the library itself and all of the power and all of the updates that come with that, rather than making you learn something that some other person cooked up. So we'll make an invisible ground plane, and Box2D has no notion of rendering, it's just physics. But invisible ground plane, we've got our down vector of 9.8. And then whenever a user clicks, we've overridden mouse down, we just add a box to the world. We get the position off of the event, the Cinder event, to know where to instantiate the box. Some exciting Box2D crap that sets some physical properties on the box and some scale and stuff. And then we just add it to, we make a pair out of a random color. We're just using Cinder's color class to make a color with a random hue, but full saturation and full value. And then we give it a pointer to the body. And when we update, we just advance the physics, pretty sort of standard for a physics library. And our draw method just iterates the boxes, sets the OpenGL matrices around what the box is telling it its current state is. So each box will have a different translation and rotation, that sort of thing. And then ultimately we call draw solid rect, that is just a built-in method in Cinder, that's just a convenience method. And when we do all that, we get something like this. So I think that's, you know, while it's not Angry Birds, it's also not wildly different from Angry Birds, but it is a running start to building something that's physically plausible and really fun to play with. The low cost of no lines of code. I mean, there's code that Tinderbox wrote for us, but it's pretty intelligible and it's a jump start to the process of building something like that. Final example, OpenCV for face detection, same kind of dance. We're gonna make OpenCV happen with Tinderbox. Rough structure of the app, so we've got our setup method, and then update will in turn call update faces. As we get new imagery, we're going to be driving this with a webcam, and then we've got our draw method. Capture is as in video capture, so that's a class built in the Cinder that just lets me interface with a webcam. I've got an OpenGL texture that represents the latest frame of imagery. And then we've got what's called a cascade classifier. That's just an OpenCV idea. It's HAR cascades, if you want to look them up, is the traditional algorithm for face detection, particularly with OpenCV. Mercifully, we don't need to understand it. I don't understand it, but I can use it. So in our setup method, turn on alpha blending in OpenGL. We'll get an asset path, which is sort of a Cinder idea. If you've ever dealt with, like, how do I find my external files, and you had a bad day, Cinder has assets, so there's just an assets directory. Anything you put in there is very easy to access, and Cinder does the weird stuff that's platform specific for, like, getting the path to the app and identifying where assets must be and stuff. Then we fire up the capture, our webcam, tell it to start. And then update says, hey, webcam, do you have a new frame? If you do, I'd like a copy of it, please. I'm going to turn it into an OpenGL texture, and then I'm going to call update faces against it. And the update faces method does some OpenCV dancing where it creates a grayscale image, because HAR cascades really just want to talk to grayscale imagery. We equalize the histogram, which is an operation in Photoshop you might be familiar with that just improves image contrast, essentially. And then we call detect multi-scale on that cascade. And that's, who knows what that does, if it does something crazy. And that allows me to get back a vector of OpenCV rectangles that are all the areas that OpenCV believes to be a human face. And then we'll make our own vector. We clear out our member faces vector, and we just call from OCV, and that's what I'm talking about when we talk about kind of a shim. So there's just a method in the OpenCV Cinder block that knows how to translate between Cinder's native types and OpenCV's native types. So we just, mFaces is just a vector of rectangles. When we draw, we say, hey, is there actually a webcam image yet? Because sometimes there's not yet. If there is, then we just draw that texture that represents the webcam. And then we iterate on our faces and call draw solid rect on them. And that's the entirety of this app. If you do that and you are in a hotel room, it will look like this. And as a final example, I want to show you a little bit of work from Robert Hodgin. And the reason I want to is because Robert essentially works alone. He traditionally has, and he works in Cinder, but some of those early projects we looked at had big teams of lots of people and professional designers and stuff. But Robert has no formal training in computer science. He has a degree in sculpture. But I'll show you two projects of his quickly that I think just show what's possible as one person working alone who, Robert's a friend, so I'm allowed to say this. I guarantee you he knows less about C++ than everyone else in this room. But he makes beautiful things with what he does know, and hopefully serve as kind of an inspiration to what one person can do with creative coding. So this is his Earth simulation, and this is all driven entirely with freely available textures from NASA. You know, he's got code driving it some too, but this is his images that you can just download. And then another project of his, this was installed at a museum in New Zealand, and this is an architectural rendering. Unfortunately, I don't have a photograph of it, but it's sort of like a walk-in Oculus Rift, maybe. So there's these 4 projectors that are creating this panoramic scene. And what Robert was asked to do is simulate this marine biological phenomenon called a boil-up, which is this crazy thing that happens in the ocean where all of these fish sort of get corralled by a certain kind of predatory fish into this crazy ball, and then like whales come, and then sharks come, and then like it's just an insane feeding frenzy on this one kind of fish. And he was asked to simulate this phenomenon in this kind of context. So he starts with the idea that we'll build a particle system with some basic rules, and each fish corresponds to a particle. So there's interactions between fish. There's a fixed radius of influence. So the extent to which a fish is interested in another fish. Within that, we have a zone of repulsion, right? So this is the like, please get off of me radius, where a fish will try to get away from its neighbor. And then there is this other zone of attraction, which is the like, well, we're family after all radius, where you don't want to get too far away from everybody else. And then within those is a zone of alignment where you're interested in aligning your own orientation to that of your neighbors. And these basic rules, if you've ever studied flocking, are pretty familiar. These were laid out in a SIGGRAPH paper in 1987 by Craig Reynolds. I believe he used these rules to write that opening bat scene in the first Batman movie, if you've ever seen that. I met him one time and he told me that. Maybe he lied to me, but I don't think so. If you put them all together, here's Robert's sort of initial results, where you can see what already feels like pretty natural motion, right? So this is, if you see the boil up in the real world, this feels pretty similar. So a nice result there. And then if you put some friggin' fish in there, you start to get something that feels pretty realistic. And it's worth saying Robert is not a 3D modeler. So in this case, he used a site, I think, called TurboSquid, where you can get 3D models that are already packaged, particularly for game developers and computer graphics people. And he put those models in, and then he wrote code that does realistic lighting and stuff, but it's not like he is an expert in Maya, for example. And then I'll just continuing, you can see sort of what happens. This is the first layer of predators. And then again, it's like dolphins show up later. It's the craziest thing. If you just saw Robert's simulation, you'd be like, you just made this up. But there's like, it actually happens in nature. It's pretty intense. And then I'll just close with this clip, which is a nice visualization of the ways that prey and predator are influencing each other here. And I like this because it looks like the sharks have lasers coming in. So again, hopefully that's inspiring just in the sense that you don't need a whole team of people to do really interesting creative coding kind of work. And I hope just overall that I've maybe brought your attention to a kind of a new way that C++ is being used, and even better, maybe inspired you to do some experimenting on your own. So thanks for y'all's time.
I just wanted to say one thing. I've been to a number of presentations, and this is like by far the most inspiring and awesome one that I've seen since I've been here. Well, thank you very much.
Thanks.
Hey, so I was wondering if Cinder is being used for any projects that have to do with music production software, or like filters applied to music.
Sure. Yeah, that's a new offering in Cinder as of the most recent release, and we have a real expert writing the audio API, but we've kind of met the first layer of needs. But if that's something that's interesting to you, there's definitely an appetite for that kind of stuff in Cinder right now. And we have, I think, a really firm foundation. It performs really well, but things like VSTs and stuff are to come. And if that's interesting to you, you should come join us. All right. Well, thank you all.